All right, I am not here today, so I am trying to help you through lesson 3, although I think it's going to be a little more difficult to understand when I can't really demonstrate for you in front of you, so please feel free to go see Miss Bright, Mr. Trainer, and Mr. Murgatroyd if you have questions, or absolutely come in and see me on the Monday after this 4-day weekend so you can get your questions answered before our quiz on Tuesday. Okay, so this lesson is on lesson 3, which is circles and ellipses. Last class we did hyperbolas and parabolas. For your circles and ellipses, we still might have general form where we have our x squared quantity and our y squared quantity, and then our x and our y and our constant. But for circles, your coefficient A and your coefficient C should be the same. And we'll kind of talk about that here in a minute. You learned about circles in geometry, and this is the form that you learned about it. It was relative to the Pythagorean theorem, right? So we would create a right triangle here, and the distance, horizontal distance was x minus h squared, and the vertical distance was y minus k squared, and then that equaled r squared. So hk is your center, and r is the radius. So if you're looking at this first example right here, it says sketch the graph of x minus 4, the quantity squared, plus y plus 2, the quantity squared, equals 25. So we could just quickly jot down the fact that we know the center is 4, negative 2, and the radius is equal to 5. So we go to the right 4, 1, 2, 3, 4, down negative 2, that's my center. From there I go right, 1, 2, 3, 4, 5. I go up, 1, 2, 3, 4, 5. Left, 1, 2, 3, 4, 5. And down, 1, 2, 3, 4, 5. I connect those to find my circle, or to graph my circle, and there you have it. All right, moving on. Of course, we're not going to just give you one in that simple a form. We potentially might ask you to complete the square. So look at example 2 where we're going to ask you to complete the square. So we're going to group our x's together. So we have our x squared plus 10x. You're going to group your y's together. So our y squared minus 4y. I'm going to move my constant term to the opposite side. So I'm going to make that negative 20. And now I'm going to complete the square for each one. So here, what do I have to add? Well, I'm going to add 25 to complete that square. And then for the second one, I add 4. Because remember, you're taking this middle term, dividing it by 2, squaring it. Taking this middle term, dividing it by 2, squaring it. So now for my first parentheses, I get x plus 5, the quantity squared. For my second parentheses, I get y minus 2, the quantity squared. And then that all equals 9, because negative 20 plus 25 plus 4 is equal to 9. So I can see I have a circle here with a center at negative 5, 2, and my radius is equal to 3. So I'm going to go ahead and graph to the left, 1, 2, 3, 4, 5, up 2, and then I'm just going to go right, left, up, and down 3 places. So there's your circle. So if you needed a little bit more time to digest that, of course you can pause at any time, try it on your own, and then come back and see that. So you can do that at any time. So I just wanted to point out, in our hyperbola and our parabola, we talked about writing these in a different form. So we could have taken this form up here and divided everything by 9, right? And so we might then have x plus 5 divided by 3, that quantity squared, y minus 2 divided by 3, that quantity squared equals 1. So now this number underneath the x represents your horizontal dilation, right? That's your horizontal dilation, or just dilation, but it's going to stretch from that center 3 places to the right and 3 places to the left. For my 3 here, it's the same thing. It's your vertical dilation, right? So then we would see we're going to go 3 places up right here and then 3 places down. So you could write it like this. We don't care. We would accept either one, right? Either of those are fine for standard form or graphing form for your circle. Okay, so moving on. blah, 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 blah. So now we are going to work on converting equations from one form to another. So for this particular equation, it says we're giving you the rectangular form. So rectangular form has x's and y's, and then of course polar form has r's and thetas. So here it says consider the conic x minus 2 squared plus y squared equals 4. So I would say you could go ahead and pause right now and sketch this on your own. So I'd go ahead and do that. So if you paused and you graphed this on your own, you should have seen that the center here is at 2, 0, and the radius is equal to 2. So I graphed over here, I went to the right 2, 0, and then I went right 2, left 2, up 2, down 2, graphed my circle. So there we have it. The second part of this equation asks us to convert the equation into, the second part of the question asks us to convert the equation into polar form. So in order to convert into polar form, you should recall that r squared equals x squared plus y squared, x equals r cosine theta, and y equals r sine theta. So again, to convert it into polar form, we want to eliminate x's and y's and try to get everything in terms of r's and thetas. So the first step would be to take this original rectangular form and to multiply it out, or to FOIL it all out. So that would leave me with x squared minus 4x plus 4 plus y squared equal to 4. Now, hopefully you're kind of seeing here, like if I have x squared plus y squared, I can group those together and that becomes an r squared. You also might have recognized that positive 4 on the left and right hand sides, well, when you subtract 4, those are going to cancel each other out. So the last thing that I'm having to deal with here is the negative 4x. So I'm going to take that and make it minus 4, and now instead of putting in x, I'm going to put in r cosine theta, and that all equals 0. Right, so my x squared plus my y squared equals r squared, and then my negative 4x, I replace that with negative 4 r cosine theta. So I'm trying to isolate it so I just have an r equals and that's it. So I'm going to factor out my r because I both have an r. Here's an r, here's an r. When I factor out my r, I get r minus 4 cos theta equals 0. So now I have two potential factors that would equal 0. Either r equals 0 or r minus 4 cos theta equals 0. Well, remember, r is representing the radius. Does the radius ever equal 0 and create something? If your radius is equal to 0, there's not even a circle at all. So we cross that out, and our polar form then is just r equals 4 cosine theta. That's it. So we move the negative 4 cosine theta to the other side. Now, based on our very first lesson, remember we learned this already. We learned if it's a cosine theta right here, that graph of a circle is going to be on the x-axis. We learned that this 4 represents the diameter of the circle. We learned that if it's a positive 4, it's going to be on the right-hand side. If it's negative 4, it would be on the left-hand side. So this should make sense, right? Maybe some of you remembered it so well, you were able to go straight to this equation. And if you're like feeling, oh, lost, I don't really know what you're talking about, then you need to pause, go back, dig out lesson 1, and review what we did for graphs, because these are definitely going to be on your quiz. And we're adding an extra element, extra level of difficulty here. So part C, this is what I mean by our extra level of difficulty here. So part C, we're asking you to sketch a polar graph of the radius versus the angle measure from 0 to 2 pi. So that means my y-axis is my r and my x-axis is my angle measure, and I'm just going to basically graph r equals 4 cosine theta. So that means I have an amplitude of 4. My period is still 2 pi, right? My amplitude is 4. So just pause right now and go ahead and graph that. See how you do. Okay, so did you get this, right? You start at positive 4 because it's a amplitude hasn't been reflected, it's positive. So we go 4 to 0 to negative 4 to 0 to 4 over the course of 2 pi units. Now what we're trying to do is we're trying to get you to see connections between this graph and the polar and the graph above. So the polar graph, which is this one to the left, versus the rectangular graph, which is the one above. So, sorry, I'm just going to try to adjust this. So we're going to look at this. It's really, really difficult for me to explain this to you in a video right now. So I'm going to do my best, but please go see another teacher if you don't understand it. So this right here is our starting point. I'm just going to put SP for starting point. So it says if we wanted to try to figure that out here, this is our starting point right here is 0 when 0, x has a no angle at 0 angle. We're at 4 for our radius. So here we are. 0 angle is the x-axis. Our radius is 4. As you go down here, right, as we go down here to pi over 2, so as I rotate through my angle, the radius is getting smaller. So as I rotate through my angle, my radius is getting smaller until I get to pi over 2, where then my radius is equal to 0. So this section right here of the graph is this section of my circle. So I notice that I started here, this is my starting point, and I rotated counterclockwise. And that's the equivalent here on that graph. Now the next part of the graph, from pi over 2 to pi, well, all of these r values are negative, right? All of the r values are negative. So of course, I'm continuing to rotate through this quadrant 2 up here, but if my r values are negative, that means they have to appear down here in the opposite quadrant. So these values right here in the cosine curve are rotating through from pi over 2 to pi, but they're going to be creating a graph in the fourth quadrant because they're all negative. So it continues to rotate around here. So the pink section is the first half of the circle, and the purple section is the second half of the circle. And so now what happens for the last part? You might be thinking, okay, well, what about, this next part and then my final part here? Well, it's just circling around that circle twice. These are all negative values, so my red is negative values. That's going from pi to 3 pi over 2. So as I go here from pi to 3 pi over 2, my r values are negative. So they're going around the circle again here. So this would be a red loop. And then maybe if I continue with my blue, this is from 3 pi to pi, 3 pi over 2 to 2 pi. They're positive values. So now when I'm in the fourth quadrant, finally, I'm back to positive values. So I'm back here, rotating around that circle. So this one cosine curve right here, maybe do 2 loops around the circle above. So we want you to make that connection because our graphs are going to get a little more challenging as we continue through the unit. So we're hoping you understand that rotation and that relationship up here from what I just drew. Okay, so we are going to ask you to indicate the starting point and the direction. Okay, so let's see down here. Another one. Okay, it says sketch the following polar relations on the Cartesian plane for 0 to 2 pi. So this has been added. Sorry, when I made your photocopies, this wasn't on there. It says for each graph, identify the starting point and indicate the direction of motion with arrows. So this is really important because this is going to be on your quiz. We're going to ask you to indicate the starting point and the direction. So you need to add this into your notes sheet. Okay, sorry about that. So let's see here. It says r equals negative cosine theta. So I'm hoping some of you right away could go right to the rectangular equation for that, right? So you could just tell me what that